In this week's laboratory, determining the mole ratios in a chemical reaction, we will have our first data acquisition use of the Vernier interface and Logger Pro system. But first, a balanced chemical reaction equation gives the mole ratios of the reactants and the products as coefficients. When some of the chemical formulas are not known, an experiment must be conducted to help determine the mole ratios. This experiment uses two common substances as the reactants, the hypochlorite ion from household bleach and thiosulfate ion, the active ingredient in a photographic fixture solution used to develop film. In the reaction, hypochlorite ion oxidizes the thiosulfate ions according to the unbalanced equation, an incomplete reaction shown on this slide. It is possible to identify the stoichiometric coefficients A and B for these reactants without knowing the products of the reaction. The process that you will use to determine the coefficients is called continuous variations. You will prepare a series of mixtures of the two reactants. Each mixture will have the same total volume and the same total number of moles of reactants. The reaction is exothermic, therefore the mixture that generates the most heat energy will be the reaction that completely consumes both the hypochlorite and the thiosulfate ions. You will use this mixture to establish the coefficients and therefore the mole ratio for the reaction. In this experiment, your objectives are to measure the temperature change for a series of reactants, determine the stoichiometric coefficients for a chemical reaction. In our procedures, we're going to connect a temperature probe to the Vernier computer interface. You will start the Logger Pro program file 09 mole ratio on your computer. Then go to the instructor's bench and obtain about 200 milliliters of each of the reactant solutions, the sodium hypochlorite and the sodium thiosulfate. Precisely measure out 25 milliliters of the 0.5 molar sodium hypochlorite solution with a graduate cylinder. Pour the solution into a styrofoam cup and nest the cup in a beaker to help stabilize the cup. Then immerse the tip of the temperature probe in the styrofoam cup of the sodium hypochlorite ion. Measure out precisely 25 milliliters with a clean graduate cylinder of the 0.5 molar sodium thiosulfate solution. Note, please do not mix these solutions yet. Now you click the Collect button to begin your data collection on the computer. You let the program gather and graph a few initial temperature readings, about 4 or 5 is sufficient, and then you quickly pour in the sodium thiosulfate solution. You stir the reaction mixture with the temperature probe. The data collection will automatically stop after 3 minutes. Then examine your graph to calculate and record the maximum temperature change. Then rinse out and dispose of this reaction mixture. Repeat the necessary steps to continue testing various ratios of the two solutions, keeping the total volume at 50 milliliters. You do this until you have 3 measurements on either side of the ratio that produce the greatest temperature change. Then you will graph on page 2 of your Logger Pro program the volume of sodium hypochlorite added and the temperature change for each of the reactions. A sample graph of what you should have is shown on this slide. This Logger Pro plot of temperature change for the individual reactions versus volume of sodium hypochlorite in this example shows that the optimum ratio of hypochlorite ion to thiosulfate ion is 1:4. The regression line that has a positive slope represents the temperature change of the reaction when the hypochlorite ion is the limiting reactant. The regression line with a negative slope represents the temperature change when the hypochlorite ion is in excess. Both of these reactions have a total of 50 milliliters, and the molarity of each reaction is held constant, and therefore, in this specific example, the optimum volume of hypochlorite ion is 10 milliliters. Therefore, again, the ratio was 1:4. Now, fill out your report and balance the reactants in your report sheet for the reaction of the hypochlorite ion with the thiosulfate ion.